Welcome to the NanoVax podcast, a NanoVaccine Institute curated podcast sharing the latest research and advancements in nanovaccines and nanotherapeutics for human and animal health. The NanoVaccine Institute is a consortium of researchers, institutes, national laboratories, and companies founded and coordinated by Iowa State University.
We are developing nanovaccines and nanotherapeutics for respiratory infections, neural disorders, antimicrobial resistance, cancer, aging, and animal health.
Our vision is that nanovaccines and nanotherapeutics will revolutionize how we prevent and treat disease.
Hello, I'm Kathleen Ross.
I am Balaji Narasimhan.
I'm Mike Ruff. This season, you will hear from experts across a range of disciplines who study respiratory diseases and antimicrobial resistance.
The first half of the season will focus on respiratory disease and antimicrobial research within the NanoVaccine Institute. The NanoVaccine Institute is pioneering the development of novel, nano-based countermeasures, such as a universal influenza vaccine. We will also talk about other emergent and impactful diseases that have radically changed how we consider and develop policy around global public health.
The second half will focus on the challenges and countermeasures to antimicrobial resistance. NanoVaccine Institute researchers have developed novel nanomedicine therapies to treat chronic disease caused by bacterial pathogens that have developed antimicrobial resistance.
Episodes will explore the different corners of these research topics through presentations on the latest findings as well as conversations among the experts. Hello, I'm Mike Ruff. I'm the Chief Technology Officer for Vaccines, Diagnostics, and Immunotherapeutics at Iowa State University, and welcome to the NanoVaccine podcast. On today's episode, we'll be talking about the intersection of livestock and human influenza. Topics will cover the connection between human and swine influenza, bovine influenza, and the highly pathogenic aspects of livestock respiratory disease. Here to discuss these issues is Dr. Phil Gauger, professor at the Veterinary Diagnostic Laboratory, also a professor in the Veterinary Diagnostic and Productional Animal Medicine, and finally contributes and leads the Veterinary Preventative Medicine graduate student programs at Iowa State. Phil has a unique background not only in serving clients and identifying disease, but he also has an active research program focused on molecular diagnostics and diagnostic medicine, swine production medicine, influenza A in swine, PRRS, PED, porcine circovirus, and porcine parainfluenza virus type 1. Phil, welcome to the podcast.
Thank you, Mike. Appreciate the opportunity to be here.
Maybe just to kick things off, give us a little bit of background of your education and where you grew up.
Sure. Well, I originate from Iowa, is where I grew up, kind of a more small traditional family farm. Wanted to be a veterinarian growing up, and so Iowa State was the college to go to.
Choice.
My undergraduate and my DVM, I got here at Iowa State, and I graduated in 1994. And then I had a great opportunity being in a private practice that was focused on primarily large animal medicine in Marcus, Iowa. Did that for 12 years, and then decided the next step would be to kind of look into some graduate school and what might happen from that. And then it was really just kind of by luck, I think, that the Veterinary Diagnostic Lab was looking for faculty at the time when I had finished at least my master's, so I was able to get on faculty within the diagnostic lab, which is really very connected, as you know, to the industry and out with our veterinarians and practitioners. So it fit well, I would say, with being in private practice myself. And then one thing led to another. I was able to finish a PhD, lead our molecular group that does the PCR testing, as well as being on what we say is our necropsy floor and taking diagnostic cases as well. So it's been an interesting place to work, to say the least. And with all that goes on in our diagnostic lab at Iowa State, particularly related to swine and swine medicine, again, it's been a big opportunity to be involved with a lot of these interesting pathogens, emerging pathogens, and things of that nature.
Yeah, cool. Well, I'm sure Iowa State's glad to have you, and certainly you're a very important role at the Vet Med, kind of the point of the spear as new and emerging diseases occur and helping practitioners make the best decisions. So today we're here to talk about not a tiny topic, influenza.
Right.
And maybe just to kick things off, give us a perspective of why influenza is important and how the zoonotic aspects of animals and humans and why that's important to us.
Sure. Well, I think it's influenza A viruses among other influenza viruses are definitely important. I think it's easy to appreciate because I think it's a topic most are familiar with when you look at it from the human perspective. We know that each year, pretty much fall and spring, we have human influenza seasons in which several thousand people are infected with influenza. And in the past, when you look at flu as well, I mean, it has been responsible for some pandemics. And you can say since COVID-19, the word pandemic has become pretty much a household term. And influenza has been involved in several of those. And if you go back to 2009, which was a while ago, we had a major pandemic with an influenza, an H1N1. And actually, that virus was highly connected to the influenzas that are circulating in pigs. And so when you think about flu in general, there are multiple different species that can be infected with the virus. And what we deal with most at our diagnostic lab is pretty much with the swine pathogens is the majority of the cases we receive. So influenza from the swine perspective is one of the top 3 causes of respiratory disease in that species as well. And then what's really interesting with particular subtypes of influenza, which we might get into a little bit more later, the H1 and the H3s, those viruses can be shared between pigs and people. And then you get into the term of the zoonotic infections and how those are pathogens that can go from animals to humans. And flu is probably one of the better known pathogens or viruses that can actually do that. So from the standpoint of the repeated infections on the human side, we have endemic infections that constantly circulate on our swine farms and the cause of respiratory disease there, and then the interplay between humans and pigs, among other species as well. It really, I guess, highlights the importance of the virus in general.
So you talked about swine and humans, but correct me if I'm wrong, I believe there's a canine influenza, equine influenza, obviously influenza in poultry. And so are these the same viruses that are in all these species or different subtypes, or maybe talk briefly about the diversity within different animal types?
Sure. Influenza A viruses are known to infect multiple different species. And like I just commented a minute ago, we're most familiar with the H1 and the H3 subtypes. But actually, there are 16 different HA subtypes that can circulate amongst our avian and mammalian species. And it doesn't mean that all of the different species are infected with all of those, but there is probably, you could say, a risk level associated with many of those. So when you look at the different species, avians are actually our waterfowl or the primordial host for all of 16 of the subtypes. So those viruses will circulate within that particular species pretty much on an ongoing basis. And then you've got the multiple different mammalian species, and we've already talked about humans and swine, but there are others in which the viruses can circulate too, and it can get pretty wild. I mean, we can get some mammals that are associated from our oceans and stuff, our seals and whales even have some subtypes that can affect them. And then you already mentioned that we can have influenzas in horses. Those are H3 viruses primarily, but they would not be exactly the same strain, although they're the same subtype. So then you start to get into talking about diversity within subtypes, and then on the canine side, there's some H3s as well. And I think each species can kind of take their turn with being kind of the highlight of the day with different spillovers that can occur. And it wasn't too long ago, an avian H3N2 spilled over into the canine species, and that was a hot topic for a little while there too. So that just mentions or highlights a few of the different species that can be infected with flu, but really it has an impact on much more than just humans and swine, which are probably, just in general, the common topics in which influenza comes up.
Sure. So, Phil, you've sort of highlighted the complexity of the virus itself and its ability to affect multiple species, but every year we have to go get revaccinated for flu because of its change. And on the swine side, it's oftentimes the same practitioners are producing new vaccines, autogenous vaccines, trying to proactively address the isolates or strains that are in their specific herd. Can you maybe talk a little bit about antigenic shift and drift and how and why flu changes so rapidly?
Sure. So, we talked about the different subtypes that are in circulation, and some of those will infect particular species, I guess, in a greater predilection than others. But even within the individual subtypes, you can have a high level of genetic diversity with any of the influenza subtypes itself. And what happens there and what causes that diversity is just pretty much the inherent nature of the virus. As far as it being an RNA virus, and when they go through the replication process, they're naturally prone to have mistakes when they're making a copy of the original virus that's replicating. And those mistakes in their genome can lead to, if they accumulate to be a high enough amount, can accumulate to create a different protein. Particularly, we're concerned about the surface glycoproteins, which are the immunogenic proteins, which are what the targets are for the vaccines. So just the fact that it's an RNA virus going through replication, you can get point mutations that may lead to some genetic diversity. And then influenzas are a segmented virus. And so they're made up of 8 non-contiguous segments. If you have 2 viruses infecting the same cell at the same time, as they're going through the process of replication, which gets pretty detailed, they can swap those different segments, and sometimes they might even swap and change their surface glycoprotein, and then you can get a much different virus. So it is a challenge for both on the human side and certainly in our production livestock side to stay current with vaccines that we know are going to be effective. And the most effective vaccines are the ones that are most closely matched to what's circulating at the farm level, or obviously on the case of people at the human level, and that can be difficult to predict. So our veterinarians that are very well versed in understanding how flu works, they're looking and monitoring very closely what's circulating at a farm, monitoring that diversity and trying to keep pace with updating their vaccines when necessary so they can maximize the control. And that definitely is a challenge for multiple reasons, but it definitely is one of probably the biggest reason that there's so much surveillance and monitoring going on the swine side for influenza.
Yeah. Maybe you can also talk about, you talked about the monitoring FLUture and what the counterpart is on the human side where they monitor.
Well, because influenza continues to become so much more complex, especially from the genetic side and trying to keep pace and understand the different, what we call clades, or the different viruses within each subtype circulating. Iowa State is fortunate that because we receive so many samples for surveillance, we get a lot of requests to sequence those viruses, and it's become very easy to sequence different components of a virus very quickly and to be very accurate as well. And so we have a lot of that genetic information about influenza viruses circulating in pigs within our database at the VDL, and that doesn't always get into public databases for multiple reasons, but one thing we thought would be useful for veterinarians and producers is to have a public website, although all the information that's contained within there is kept confidential. But what it would present is just the genetic data that we have, and what it can show you is the different frequency of detection of these different genetic clades that we talk about within, particularly what we're talking about is the H1 and the H3 subtype. And so it can show you the different changes in the frequency that these different strains, genetic strains of the virus, will kind of rise and fall. What would be the most common ones? And then they would really represent probably the viruses that are the most risk at infecting a production system. And so we can keep track of that. Among other things, there's always some emerging influenza viruses. Some of those actually come from people, and they spill over from people into the pigs. So then you can easily recognize when you have something that's much different.
Yeah.
Or we have pigs that come from Canada and other regions, and different geographic regions will have their own predominance of a particular strain. And those do move with the pigs. And so when they maybe move long distances with the pigs into a particular area, if it's a successful virus, that particular strain might become established as well. And so it just further highlights the complexity that flu can present and why it can be such a challenge. On the human side, they're sequencing probably any influenza that gets detected, and those get sent to the CDC. They're sequencing those. They've got also websites available, one called FLUView, in which you can monitor which subtypes are circulating. You can look if there's variant influenza viruses circulating in people, and those might represent zoonotic infections. So they keep very close track of that as well. So I think between that and now with our FLUture website that we host here at Iowa State, it just helps get a little bit more information out there into the public as far as what's circulating to try to keep better track of what's going on in the flu world on the pig side.
Yep. So as a veterinarian that would be calling into you and maybe have used that website on my specific herd, how would I use that information? Would it be to select isolates for autogenous vaccine production? Would it impact animal movement? Would it change diagnostics I do? How is it used practically?
Mm-hmm. Well, I think a lot of the questions that we used to get before we had the website is a strain would be sequenced, and the farms are doing their own genetic monitoring, and it might be a new sequence or a different strain of the virus than what they had before. And the epidemiology becomes important for the veterinarians and the production systems they serve. And so they would call and ask, this is new to our system. Have you seen it before and where? And so now they can put their sequence into this program, which we call blasting it, and it'll compare it to all of the viruses we have in our database. And it can return back, how many times we've seen it, how close it is in percent homology, matching the nucleotides between their virus and what's in our database. And also it'll return back which states it's been recognized in. And so I think that's been helpful for trying to understand where the viruses have been observed or recognized, and what you could say is close to being the prevalence or at least the frequency of those that are being detected. And they understand better the risk that could be associated to their production system and whether or not it would be worth it to put that into their vaccine as another antigen, we call it, to help protect against it or not. And so that's one way that, probably one of the major ways that that's been helpful. I think also our animal health industry has used it quite a bit, also looking at it primarily for the same reason, but they're wanting to know how often we're seeing particular strains and if we're starting to see a particular genetic clade of the virus increase as you get this ebb and flow of the different strains of the virus, and what might be important to put into some of their products that they're putting out there from an autogenous standpoint. And what they can do is match the production systems they serve with vaccines, their products to what's circulating on the farm.
Yep.
And they're wanting to keep ahead of that. FLUture does a good job of doing that, and also looking at it again from a regional geographic perspective and what's circulating in different states and different regions of the U.S. And so it's been a useful tool, I think, from that perspective, especially with helping deciding on vaccine antigens and things of that nature.
Yeah, cool. I want to give you a plug as well. You have FLUture, but you also have one on PRRS as well. Mm-hmm. What's the name of that website again?
We call that one PRRSView.
PRRSView, okay.
Pretty much does the same as FLUture and helps to answer similar questions. Yeah.
Well, great tools that are publicly available to all. So one thing I do want to circle back to, because I think you're probably one of the larger experts in this area, but you talked about shift, drip, and then maybe more importantly, you talked about reassortment of different flu isolates. Talk about how within, I guess, swine, maybe specifically in humans, how viruses may shift back and forth. I think people generally think about getting influenza from animals maybe, but the opposite can be true as well, right?
Yeah, that is true. So we mentioned a little bit earlier about zoonotic infections, and those are the pathogens that can go from the animals into people. But when it comes to influenza specifically and this bidirectional transmission that can occur fairly easily between pigs and people, we see viruses that we know are human strains of flu that then we detect with our genetic sequencing in samples we receive at Iowa State, and that's known as reverse zoonosis. And basically, pigs are kind of unique in the fact that their respiratory tract has two receptors that are able to attach human strains of flu, and then they also have the receptor for the avian strains as well. So they're susceptible to both strains, and just the close proximity now that we have between human workers at farms, or you look at agricultural fairs where you have a lot of our youth spending a lot of time in very close proximity to their pigs because they want to care for them and are concerned about them. You create opportunities for that transmission to occur. Yeah. So you've got the receptors that are there that are similar between pigs and people. Pigs in particular can have both receptors. And so it's created this interplay of H1 and H3 viruses that can go kind of back and forth. The pandemic H1 virus was made up of swine segments from influenzas that have been circulating in pigs. And that became a big deal, as far as the pandemic in people. But we continue to see that strain actually spill back over into pigs. So we'll see some H1 pandemics in addition to all of the swine strains that are there. And then it's interesting. It seems like when there's high pressure of influenza detection on the human side in particular seasons, when you could say flu on the human side is kind of worse or there's a lot more infections, we see more spillovers of those viruses than into pigs as well. And right now we are kind of in the process of monitoring an H3 virus that's circulating in pigs that did have a human origin, and we'll see if it becomes established, becomes endemic. And then just the challenge with that is you've got another clade or genetic clade of viruses circulating in pigs, which adds to that overall ecology or genetic diversity, and the challenges just continue from there.
Yeah, incredible. Well, if you think about, I smiled when you talked about proximity. I just was at a county fair, and these show pigs. There's kids laying in the hay, sleeping next to their animals, and so that's clear there. But also, if you go to a commercial farm, 8,000 animals in a barn, and you're doing whatever vaccinating or taking temps or whatever. It's a pretty intimate relationship when you're in the barn, not surprising that it happens. So let's switch gears a little bit and talk a little bit about vaccines. Certainly vaccines are used commonly in pigs. Certainly they could or should be commonly used in humans. How and why is that important?
Well, when it comes to trying to control flu, which is ubiquitous, which means we can find it anywhere, and that's really worldwide, it's difficult to control the virus with some of the more traditional methods, and those are still important, and probably the big one is biosecurity. So we do what we can with that, but nothing is probably better than using the prevention that can be offered by a vaccine. So that becomes still a very important tool to use on our swine farms. A lot of the sows or breeding animals on farms are what's vaccinated, and then they can provide maternal antibody, no different than people, to their offspring that protects them so that they're not getting infected with the viruses at a young age. So vaccines still are what we have available as our best method of control. Biosecurity is very good on these farms. There's a lot of monitoring of the animals that come and go from a farm to make sure they're not infected to share new viruses. But again, influenza is just very ubiquitous, and it can be very difficult to control because of that. So no different than on the human side, vaccines are important for control as well. I think that it's accurate to say on the human side there's a little less diversity than what we see on the pig side, because there just is a huge breadth of diversity, and probably because swine production has to involve moving pigs and moving their viruses as well, and some mixing of different strains there, and that can add to some of that complexity. But when it comes to vaccine selection, which we already talked about as a challenge, that's different than what's done on the human side, where there's kind of a more formal process of looking at what's expected to be the most prevalent strains on the H1 and H3 side that they can put into vaccines that are going to be similar kind of across the board from the different companies that produce them. On the swine side, and mentioning how we have this huge breadth of diversity, there isn't a formal process for that selection. So it really comes down to what can be done at the farm level, which is most applicable because, again, kind of like what we mentioned before, you're wanting to match the strains circulating on the farm as much as possible to what's in the vaccine product and what you're immunizing with, because then you're going to get your best control. So that's a lot of the push for the surveillance that takes place, and a lot of the genetic sequencing, keeping track of what's known to be circulating on the farm, because if you don't know, you're just not going to be able to establish the control that's needed. And then making informed decisions on the vaccine antigens that go into a product, and why, really, as you know, Mike, a lot of our vaccines now are made as farm-specific vaccines. You could call them autogenous, different things of that nature. But again, it's just all the goal to try to maximize the similarity between vaccine and what's circulating on the farm to maximize the control. So considering that's our best method of control, vaccination is still really important, and it takes a little extra effort to try to decide what to put into a product versus kind of, in contrast to what happens on the human side.
Sure. So as you know, my background is in vaccine development, but we all lived through COVID. And so I think what we learned there on the human side was that the expectations of vaccines maybe is different for different people. So from my view and my background, I see vaccine use as having an individual benefit to clinical disease, but also having a benefit to a population of either people or animals. So if I have shed less virus to others, that's positive as well. But there are very few vaccines that produce sterilizing immunity. So, you get vaccinated and you're bulletproof. And most vaccines tend to, reduce the severity of clinical disease or knock down the level of virus, but not take it to zero. Is it the same in pigs? What should a practitioner expect if they vaccinate their pigs? Is it sterilizing immunity or something more practical?
Right. The sterilizing immunity concept is really difficult to achieve, I think, with any of the species, and it gets above really the expectation. And maybe when you look at the individual level, and you kind of mentioned differences in individuals, you may prevent most of the infection taking place. But for the most part, you don't prevent infection, you prevent the clinical signs. But I think we need to keep in mind that, obviously when preventing clinical signs, we want to prevent welfare issues for the animal. We want to keep them happy and healthy. And we want to reduce the economic consequences of the infection too at the farm level. And so those are a couple of reasons why we still want to vaccinate. I think it's safe to say, Mike, though, that with vaccines, in spite of not being sterilizing immunity and having some infection, we still reduce the level of that infection. We're not getting as much replication, which then translates into what's being shed from the individual animals to the population, and then you reduce the transmission as well, and that's all beneficial from the viral control standpoint for the welfare of the animal, and just trying to keep, the idea of this genetic diversity continuing as well, which is going to happen under these situations where we have naive populations and you have kind of a viral explosion, so to speak, for lack of a better term, and that allows for greater opportunities for the virus to take advantage of, the genetic mutations during replication and reassortment that we talked about as well. So I think we need to keep it in perspective of what our vaccines can do, but there's a lot of benefit there to the vaccines when it comes really to replication in addition to control of clinical signs, shedding and transmission, and that's all beneficial. Yeah,
and you mentioned animal welfare. That's certainly very, very important today. Right. Another aspect for consideration is whether it's flu or PRRS or any in these other diseases, they oftentimes set up animals for secondary infections, many of which are bacterial.
Right.
So there could be some benefits in terms of antibiotic reduction as well. So
you bet. So if we, if you reduce the primary invader, like what flu would be considered, then you can help control some of those secondary pathogens that are always there, but really are looking for the opportunity in the pig to cause a problem. And that happens when there's a primary issue, primary pathogen that's stressing the animal, immunocompromising the animal, things of that nature.
So I'm certainly not an expert in this, and you may or may not be as well, but we're starting to hear in the lay papers and industry about some outbreaks in influenza in poultry, and in those cases, our governmental policy is to euthanize and take those herds down. So that can sometimes be thousands, hundreds of thousands, maybe even millions of birds. And so a question I get routinely asked is, why don't we vaccinate those animals? We vaccinate pigs, we vaccinate humans. There's even some limited, vaccine use in dogs. So why don't we vaccinate chickens?
Right. So it's a good question and a very relevant one, and I think keeps coming up more and more because of the current H5N1 situation. It started this particular strain in 2022, and it's continued. And it's had a huge impact on the poultry industry, especially here in Iowa, where we're number one in the number of layer animals and egg production. And those birds are definitely susceptible, and we've diagnosed those cases. And in those situations, those farms with a huge number of birds have had to go through and euthanize them all, and that's very difficult. So from the vaccine perspective, I think that we could have very good vaccines available, but then you get into all of the extraneous factors that come into play when you talk about vaccinating for, in particular, H5, which is kind of a highly sensitive subject, right?
Mm-hmm.
So you have both the logistical, the economic, and the political aspects of vaccinating. And the logistical part is maybe making vaccines available to everyone, but still that probably should be possible. But then the economic part can be the cost of the vaccine and the investment there. But yet you would think that would far outweigh the continual, euthanization and the current practices that we use in order to control H5 on the poultry side. And the political one certainly is too, also very big, Mike. And so there's a lot of trade implications when you have vaccinated poultry animals, and those trade implications can also have a huge economic impact when it comes to trade and what agreements have been put into place. And hopefully there can be some more discussions around vaccinating animals and what can be still continued with the trade that's so important for the economic aspect. When you vaccinate animals, whether it's birds or other mammals, just like we talked about a minute ago, Mike, you really don't maybe prevent all the infections, but you do prevent clinical signs. And so I think some of the concerns from the political standpoint as a vaccinated animal wouldn't be recognized as potentially being infected because they're not sick.
Mm-hmm.
But I think, that's worth a lot more conversations because coming from my world, the diagnostic aspect, we have excellent tests in place in order to be able to test and monitor and detect these infections, whether the animal is sick or not. And so hopefully if we can continue to create confidence in our current diagnostic tests that we have, we can be reassured that we're, not moving infected animals at the time and things of that nature. But again, I think the three big things in combination are just the logistical, economic, and political aspects of vaccinating, which are some challenges right now that, again, like I said, are worth more discussions, and hopefully that can take place and try to get around this continual euthanization that's going on at the farms, which has been a method of control and has appeared to work, but it's probably not one that I think most would say is a sustainable one.
Yep. Yeah, I think with today's technology, both on the vaccine development side, where you have subunit vaccines or even prescription products, as well as the advanced diagnostics, we would have the ability to develop a vaccine program that could differentiate wild type versus vaccine exposure. And
you bet.
I know that is under discussion. You mentioned about the political and the import-export part of it. I was recently involved in a discussion. Again, I'm not an expert in this, but my impression was that the people that produced eggs were more open to vaccination than the people that raised broilers. And I suspect that that's part of the import-export discussion. And the industry itself is probably not aligned on that, which is probably part of the reason we're still here.
Correct. And those different entities on the poultry side have just had been impacted differently with our current H5 situation. And so that has played a role in that as well. And I think on the layer side, they're more open to it because, like we just talked about also a little bit ago, this current strain of H5 has been going on since 2022, and it's a little bit different because it's not kind of mitigating itself with time, and if it's going to continue to be a problem like it is, then the conversations about what alternatives we have probably needs to come into play.
Yep. So let's switch gears a little bit. You and I are both researchers at heart. You're more active in the lab than I am, but new and emerging diseases are exciting, and they are probably part of the reason we're both in the industry we're in. Within the last 120 days, Iowa State, I think Dr. Drew Magstad specifically, was part of a team that identified the first cases of bovine influenza. Tell us the story, at least from the insider view that you had.
Sure. No, it's an interesting story, I think, because Iowa State is known for our swine diagnostics because of our location, and not so much of bovine, even though we have definitely bovine diagnostics and tests and all that available and serve not only our state, but the whole country from the bovine side. But, particularly within our dairy farms and the lactating dairy cows, I can remember back in January the stories about a mystery disease. And I think it became a mystery because it started off like what other diseases can present as far as in a lactating lactating dairy cow, you're having mastitis, you're having animals that don't feel good, they have fevers, and then they go off feed, and you get reduced rumination and things that cause issues with milk production. And so that was going on for a while, and I think it was a mystery because they weren't responding to the traditional treatments. And so then you have to start to think outside of the box. Dr. Magstad is connected very well to the bovine industry, and there was a veterinarian in Texas who happened to be an Iowa State grad. And so they were struggling with the diagnosis and trying to understand what's going on. And you start to reach out to as many different entities as possible to get input to try to find some answers. And there was a lot of different tests that were done. You look to rule out what you expect to be the typical diseases, whether viral or bacterial. And that had taken place. We've got technologies where we can take a sample and do whole genome sequencing, they call it, but it's a non-biased sequencing. So you can look for multiple different pathogens there. And even some of that wasn't being helpful because probably the sample type that was being looked at wasn't the best one. So then, when you've exhausted all your differentials of what you expect to be there, you think outside of the box. And Dr. Magstad thought, the high path situation continues, especially throughout the Midwest. We had multiple poultry infections still taking place. And we thought, maybe we should be looking at this milk because we know we have a mastitis and be checking for the H5 virus. And sure enough, there it was. And our diagnostic lab, like several others, has all those tests available in order to screen for influenza A viruses. And then as part of our network with the National Animal Health Laboratory Network, we've got these specific PCR tests to characterize the virus, and that's one to subtype it. And we're able to use those on any mammalian species, and we thought it would be best to try and make sure we rule out the H5, but sure enough, that was positive as well. And then we're obligated to contact our federal National Veterinary Services laboratories, and things really kind of took off there. So it was a unique story. Took some thinking outside of the box, a connection between an Iowa State grad who was just reaching out as a veterinarian trying to help their clients understand what was going on, and one thing led to another. And here we are with what is really a unique situation with our lactating dairy cows being infected with the high-path H5.
Yeah. Great story, great example of the expertise not only we have at Iowa State, but our animal health industry in general has, to be able to find a virus, to be able to sequence it.
Yep.
PCR developed tools so rapidly. It just makes you smile and give you confidence that, technology is being used in the best way.
Sure.
I would say, too, that I'm pleasantly surprised how well the industry and the public has responded to this information. It's been rational. I think the cattle industry and all you and others that have talked that clearly most milk is pasteurized, and then if that's the case, that rapidly inactivates the virus, and so it's safe. And so when that first came out, I was like, oh boy, somebody in the media is going to get hold of this, and it's going to be ugly. But it seems to be a really rational and smart approach to how they're managing the message.
Yeah, you bet. So I think you can kind of predict that there would be those types of concerns emerge, and so there has been a lot of work done rapidly, whether it be kind of formal research or just going out and looking to confirm that the food supply is safe, milk is safe, that things are okay when it comes to those things that the consumer or people would consider to be a risk. So that's all been okay in that aspect. Now it's just answering a lot of other questions that have come up, just as far as the hows and whys for this particular virus. How do we go about preventing this? And obviously we want to keep our cows healthy because that's when they can produce the most and is what the goal is from a welfare standpoint, just across the board regardless. And so you'll see a lot of good research coming out of this to understand it better. From the consumer standpoint, again, there's really no concerns that should be related to pasteurized milk anyway. And then I think with the bovine species now becoming infected with an influenza, particularly the H5, that was a surprise. And the history on the bovine side for influenza hasn't been as prominent as all these other species we talked about, or even, when you think of some of the mammals that are in the oceans and things like that can be infected. So trying to understand how this spillover occurred from avians probably into bovine, and why it's now continued to persist is a lot on people's minds. And then it also highlights, this interspecies transmission of flu, which is a big component of influenza A's in general, and how if it can happen to bovines, then what do we need to do to be prepared, just to be preventative from multiple other species in that aspect, and that includes humans as well. And so there's a work in progress to have vaccine candidates in place in case there would be something more on the human side. And of course, for our domestic livestock species, we're looking at those alternatives too from a vaccine standpoint, biosecurity enhancements and things of that nature to help prevent it.
Yeah. So Phil, you mentioned that pasteurization really provides a safe cushion for the food supply and mitigates really any concern about the influenza in cattle milk. But not all milk is pasteurized. Maybe talk about what's the risk of that and ramifications.
Sure. Well, I think when it comes to non-pasteurized product or milk, or when you consider drinking raw milk, there would be definitely a risk there associated with it. When it comes to H5 in particular, we know that there's been human infections with H5, and that can occur in some of our farm workers that have been exposed to it that way. And there's been other reasons that H5s have been transmitted amongst people or between people and animals. So drinking raw milk would be a risk. I think that there's probably research in place to quantify what that risk would look like. But, that would be true for other pathogens as well that humans are susceptible to. So I think there's an inherent risk there, especially with this H5. And if you look at models, so to speak, from the research side, one of the interesting factors that came out of our discovery on the dairy side is then you have feline species or cats on farms that actually over years have just been able to be fed, the raw milk from some of these cows from the sick pen, because that milk does not go into the food supply anyway. They have to be healthy. But when it comes to some species, that they can get access to that, and they have been infected with the H5 as well. So I think there's definitely some risk. It probably will be quantified more so with some future research, and I think that just should be considered and be on people's minds as well.
Well, congratulations to the whole ISU team. I mean, as an alumni, I was pretty proud of us leading the effort there, and Drew and you and others that really have taken a leadership role to help protect our food supply.
It's part of the fun of the job. Yeah. A lot of things that are on the cutting edge, and I guess a person can be surprised fairly often. We expect some emerging pathogens to come along, especially if as technology gets better and you look more, you find more.
Yeah.
But be on the cutting edge across the board for all of our species, and to be involved in really playing a big role in animal health is just a fun and special team to be a part of, and so it makes us proud as well.
Cool. Last question, maybe just sort of a fun softball question. You're a researcher at heart. You have an active research program. You're actively collaborating with NEDC and partners all over the world. What's going on in the influenza research world that excites you the most right now? What do you see tools coming available or the next big thing?
Well, obviously because of, even before it was discovered to be in the dairy species, swine have always been a risk for H5 infections as well. And so now that we've seen it spill over into dairy, it's become even a bigger topic. At least with the research done with this actual strain that's circulating now, this H5N1, that's been put into pigs, pigs are susceptible or at risk, but it just doesn't seem to like pigs real well. And so we don't see a lot of, in particular, a lot of virus being shed per se, or a lot of transmission from pig to pig, and so that's a good thing. I think you'll see a lot more research coming along with H5. The challenge there is you have to have particular facilities because it is a controlled virus. But on, just in general, the H1 and H3 side, there's always a lot of research going on. I think definitely with looking at what viruses can present a risk for zoonotic infections back into people. And then I mentioned our opportunities where we get to do all this sequencing and find these H3 viruses from people going into pigs. And so we're able to isolate those and wanting to look at those. The research that I think would be very good is looking at their pathogenesis in pigs and why they spill over, and what is it about the genetic makeup of those viruses that would allow one to persist and become endemic in pigs versus others that do not. And I think that would help us understand that risk or that transmission that occurs between pigs and people, and help with some preventative efforts that go along with that. And then I think there's always a lot of research going on related to different types of platforms of vaccines, and trying to find one that provides as much broad protection against all of these genetic clades and viral diversity, I guess, in general, that we've talked about quite a bit here on the podcast. And those different platforms that are being looked into, just ones that, again, create broad immunity to be able to protect against all of the genetic diversity is a big area of research of interest. And we can get involved in providing some of these unique strains to use for challenge studies for those, and that can become interesting as well. And then another exciting area related kind of to the vaccine side, but is just really understanding what creates antigenic diversity within these viruses. So where does the virus change within its genetic makeup that then all of a sudden it no longer is protected by the current vaccine being used on a farm? And some of that research has already been done, but I think we've got a ways to go because we've maybe looked at a particular strain of virus, so to speak, or subtype. There's many more subtypes, or within, for example, our H1 viruses in pigs, there's a huge amount of genetic diversity there, and it's going to probably vary from the antigenic side of what changes to make it be antigenically different, and that's going to take some time to look into, but that's also another exciting area that's always going to be kind of high on the list for what's being done.
Yeah, no shortage of fun things to chase,
right.
Are there? That's
you bet.
Awesome. Well, Dr. Gauger, thank you for your time. This has been enlightening, and influenza is a topic that's important to all of us, whether it's for our family and ourselves or whether it's our pets. Certainly very, very complex topic, but feel comfortable that you and others are on the front line helping keep this under control. Thank you for joining us for this discussion. Other episodes of this session will explore other facets of the livestock-human disease connection and the ways we can understand it better to protect public health and improve global food security. Please check out the show notes to learn more about the research discussed in this episode. Please be sure to like and subscribe to the Nanovax podcast in your preferred app or media player.